Welcome back to EESC 315. Today I'm joined by Bart Koppe. He's going to be discussing his topic of assessing human health and environmental impact assessments. And keep in mind that often people like Bart will also do an ecological risk assessment using similar techniques to what we'll be talking about today. But today we're focusing exclusively on human health. Bart is a senior environmental health scientist. He leads the environmental group with Intrinsik. Intrinsik does both the human health and ecological health risk assessments for many environmental impact assessments across Canada and probably elsewhere. I've been fortunate to work with Bart for the past 15 years or so on environmental impact assessments. So I'm glad to welcome Bart today. So Bart, take it away.
Okay, thanks, Jerry. So the focus of my talk today will be on how we assess human health in environmental impact assessments. So I'll go through different stages of the process as well and touch a little bit about kind of what the next steps are or which way we're moving with respect to how health is assessed in EIAs. So I wanted to give you a little bit of background on me, just to show that, you know, I am somewhat legit. I have a background in biology and environmental toxicology. I've got over 20 years of experience in risk assessment and toxicology, so specializing in human health related issues, exposure assessment, and risk communication. I've been a technical lead on dozens of health assessments on really large industrial applications across Western Canada. And I'm currently acting as an advisor to the BC Ministry of Health, Health Canada, Alberta Health, as they develop their guidance on how to do human health risk assessments. I've also been a witness at joint provincial and federal regulatory hearings and environmental appeal board hearings, again, related to the field of human health risk assessment. And just a quick overview of my company, what it is we do. We're a science-based consulting firm. We specialize in toxicology, issues related to toxicology, human health. We've been around for over 25 years, and we're privately owned, so employee owned, and we've got offices across the country. We've got a couple of offices as well in the United States. The markets that we serve relate to pharmaceuticals, biotechnology companies. We do chemicals and consumer products work, health and environmental sciences, and then as well, crop protection products. Our clients range from industry to all levels of government, so federal, provincial, municipal governments, and as well we do, in Western Canada anyway, we do a fair bit of work for Indigenous communities as well. You can check us out at intrinsic.com. So just brief outline of the presentation. So I'm going to talk a little bit about how health fits into an EIA. Then I'm going to talk about human health risk assessment, what that process looks like. So what the principles are, what the framework is of an HHRA, and then the 4 critical stages of a human health risk assessment. So that's the problem formulation, which is the planning stage. There's the exposure assessment, toxicity assessment, and risk characterization. And those 4 stages, which are often referred to as the risk assessment paradigm, has been developed over time by agencies like Health Canada, the United States Environmental Protection Agency, and the World Health Organization. So over the last 20 years, it's really been well characterized and it's well defined. And at the end of the presentation, I want to talk a little bit about how things are changing, the movement, not necessarily away from human health risk assessments, but that there is kind of a movement afoot where the regulators and stakeholders, so members of the public, are more interested in kind of looking at health through a broader lens. So to begin, so how health typically fits into an EIA. And I've got a photo here. Like when I first started working on this, we could basically do an EIA in one binder. You know, we would have the air quality assessment, water quality assessment, and then we would have a full section on hydrogeology, things like that. Probably all things that you've learned about. But you know, human health always seemed to be an afterthought at that point. And now we're at the stage, you see, where the EIA process has become very, very comprehensive and complex, and where we're able to fill anywhere between 6 and 8 binders of just information related to the EIA, so the application of that project. So it's developed, it's evolved over time. It's gone from a very simple process to a very complex process. And that increasing scope, at least for the human health risk assessment, probably for the environmental impact assessment as a whole, it's partly due to pressure from regulators and members of the public, kind of a sophisticated component of members of the public, where they recognize that there was probably a need for a separate assessment of risks to human health. So that instead of just relying on an air quality assessment or a water quality assessment, where in the past you would have an air quality specialist who would say, look, you know, our predicted ground level air concentrations meet ground level air quality objectives, so there's no need to do anything further than that. Probably similarly on the water quality side with respect to human health, if a water quality specialist could show that you're meeting drinking water quality guidelines, what's the point of going any further than that? So it really, with the movement towards a more comprehensive human health risk assessment, there's a movement from going through a qualitative process to a quantitative process. Over time as well, over the last 20 years, when I look back, I see that the work that we did, they were basically equivalent to screening level human health risk assessments. Those wouldn't fly today anymore. It was basically just a comparison against ground level air quality objectives and water quality guidelines. Now it's a much more comprehensive and involved process. And then the guidance on human health risk assessment in the past was really based on guidance on contaminated sites, and that guidance was developed by by Health Canada and the US EPA. So I guess before we get into the nuts and bolts of a human health risk assessment, I think many of you probably recognize that there's different kinds of risk assessment. There's what you would call a failure analysis, so mechanical parts in an airplane or in a car. There's a hazard analysis, so what's the chance of an explosion or a fire occurring? And usually the endpoint for something like that is a fatality. There's a risk assessment related to actuarial sciences or natural disasters. Insurance companies rely heavily on that kind of information. But what we're talking about today is a human health or an environmental risk assessment with a focus, although there's three things that you could be looking at. You could be looking at chemical hazards, biological hazards, and radiological hazards. What I'm talking about today, what's part of typically in BC or in Alberta or other parts of Western Canada, with some exceptions in Saskatchewan, we're focusing on chemical hazards. So what are the risks associated with chemical emissions associated with that project? So, an evaluation of potential risks, it needs to have three things to occur at the same time. So there needs to be overlap between what we refer to as exposure. So there has to be an opportunity for someone to be exposed. There has to be a hazard there. By that hazard, we mean that there needs to be some sort of chemical, and there needs to be a receptor present. So a receptor would be a person. It could be you, it could be me. And when all those three things overlap, there's a risk. Now, in the absence of any of those three things, there really is no risk. And that needs to be recognized when you're doing a human health risk assessment. So most of the regulations in Canada and other parts of North America are based on risk assessments. So when we talk about water discharge limits, water quality criteria or guidelines, that's based on a risk-based approach. Air emission limits, ambient air quality objectives, even occupational health standards, cleanup criteria for soil and sediment, those are based on a risk assessment process. Even things like food recall, so acceptable contaminant levels, or maybe what we refer to as tissue residue levels in fish, they're based on a risk assessment. And fish advisories are banned. So there's parts across Canada where certain streams and lakes have fish advisories on them that could be based on mercury concentrations in fish, could be based on dioxin and furan concentrations in fish. Now the determination with respect to that fish advisory, so acceptable levels of risk, it's all based on a risk assessment process. So I wanted to quickly just touch on that development of human health risk assessments over the last 20 years. And I talked about this a little bit already, this idea that the early design of human health risk assessments was really regulators trying to get a grasp of how risks should be assessed for contaminated sites. So this probably started in the mid-'80s. Before then, there'd already been a real upswing in toxicology and how that's assessed as part of pharmaceutical applications and things like that. But when they started looking at environmental issues related to contaminated sites, there is no real clear guidance offered by Health Canada or the US EPA. So in the mid-80s, they started developing this guidance, and again, with a focus on contaminated sites. And you'll see here in the fourth bullet that Health Canada, since 2010, has really started offering clear guidance on how to do human health risk assessment. They've got one for preliminary quantitative risk assessments. They tell you how to select toxicological reference values for your HHRAs. They tell you how to do a more detailed quantitative risk assessment. They've got guidance for how to do a radiological risk assessment. And now Health Canada is in the process of updating some of that guidance as well. And then throughout that time, the provinces started developing their own guidelines for doing HHRAs. Both Alberta and BC were probably kind of ahead of the game with that. And then Ontario has developed their own guidance as well. But then more recently, in the last 10 years or so, the regulators wanted to start offering some guidance on presenting a how-to for doing human health risk assessment for prospective projects. So basically HHRAs with an eye to the future. And that's what fits into an EIA. So a contaminated sites HHRA process doesn't necessarily apply to an EIA, because an EIA by its nature is forward-looking. Really what you're doing is looking for future impacts associated with that project. So in 2016, Health Canada released its guidance for evaluating human health impacts and environmental assessment, but that focus was really on air quality. At the same time, they released something for drinking and recreational water quality, and then 3 years later, they actually came out with a guidance document for doing HHRAs and EIAs. Alberta Health had kind of beaten them to the punch already in 2011. They had come out with their own guidance on HHRAs and EIAs with a special focus on Alberta. And if you read through that guidance document, it reads a little bit like it's intended for large oil sands industrial applications, because that's where so much of the activity was for Alberta. And then they updated their guidance in 2019. Now the BC Ministry of Health is working on their own guidance document. That's a work in progress. So they've got a draft out. I think they released it in 2019. I'm part of that review committee, so they're hoping to finalize that in short order. So I think that will probably come out sometime in 2021. So really, why do we do an HHRA and an EIA? Well, the first reason is because the government tells us that we have to. Not always, but the government often does. And there's a clear requirement under the BC Reviewable Projects Regulation and the Environmental Assessment Act that any project that requires an EA should do a human health risk assessment. They don't tell you that you absolutely have to do an HHRA, but they do say that you have to at least look at health. Another reason to do it is a project could see a lot of public attention or public concern. I've had clients who decided to do that even though there's no regulatory driver for them to do an HHRA. They recognize that their project probably would trigger a lot of interest and a lot of concern, and so they decided to do it. Another reason to do it is for companies or for applicants, and I'll use the term applicants, proponents, and companies interchangeably. Basically, they all mean the same thing. Sometimes they do it just as an exercise of due diligence. They want to make sure that their project is not going to result in an adverse health effect.
I'll just add something to that as well, Bart. So we've talked about valued components in this course. And so, for example, if we had the circumstance that you were talking about earlier, whereby you've got air quality results and water quality results, and these all look fine, most communities still want to see what that translates to in terms of human health or aquatic health or ecological health. And so doing an HHRA would sort of answer that question of does it matter, or how does it matter, or what does it mean to me, as opposed to just seeing some chemical concentrations in the air or the water. So it's also about bringing it to a receptor that people really care about, namely our own health.
Yeah, no, I think that's a good point. If the HHRA really kind of offers this so what, explanation. So it's presented under single cover or as part of one section. So the reader doesn't have to go back to the air quality section or the water quality section. I know that HHRA practitioners have been criticized in the past for being a little too technical in their writing, but I think there's now, I think there's a movement towards offering a more plain language summary of some of these effects. And I think if the reader was just to rely on the air quality assessment or the water quality assessment, they'd really struggle just trying to contextualize some of these risks and what it really does mean with respect to their own health. So yeah, the four key stages of human health risk assessment. There's the problem formulation, which is really the planning stage. That's your opportunity to put some practical boundaries around the human health risk assessment. And as part of that planning stage or that problem formulation, some of the key steps involve, the identification or selection of chemicals of potential concern, or COPC. You'll see that a lot, that term being used. As well, the identification of receptors of concern. So again, receptors are just people who are potentially at risk. There's an evaluation of the applicable or relevant exposure pathways associated with that project. And at the end of that, you combine those three things and you develop a conceptual model. And I'll touch on that a little bit later on in the talk. Second stage of the problem formulation is the exposure assessment. So that's basically when we take the information from the air quality team or the water quality team, and we determine what level of exposure is associated with the chemical emissions from the project. And then there's the hazard and toxicity assessment. Basically, it's a determination as to how toxic some of those chemicals are. And then the risk characterization basically are your results. That's the results of the HHRA and your discussion all wrapped into one. So what are the risks to the people who are potentially at risk? And then as well, you need to include in that risk characterization two other things now. In BC, there's going to be a clear requirement where you do a pretty robust assessment of what the baseline health conditions are for that community. And then as well, it's not listed here, there needs to be a detailed assessment of some of the key sources of uncertainty and what that means with respect to the final risks. So this is just a depiction of what's often referred to as the paradigm. It shows the four key stages. So the planning stage, problem formulation. Side by side, you've got the exposure assessment, the hazard assessment, but you see that the problem formulation really informs those two stages of the HHRA. And ultimately, the exposure assessment and the hazard assessment then flow into the risk characterization. Now, if as part of that risk characterization, you identify unacceptable levels of risk, there's an opportunity for some risk management. So it could be the implementation of mitigation measures. It'll probably also involve some level of monitoring. It's really rare for there to be an HHRA without any sort of requirement for monitoring at the tail end of it. And then to the sides of that, you see that there's a public consultation piece, so stakeholder engagement, and then as well the collection and validation of data. It's the collection, could be air quality data, water quality data, soil data, sediment data, could be fish, you name it. It could all be included as part of the HHRA.
And I'm just going to reinforce something you said there. So you talked about mitigation and monitoring. So if we do an environmental impact assessment and the only outcome was to just identify some risks and to maybe point to some adverse impacts, I think the value of the EIA would be very low. Where the real value comes in is in that mitigating the risk. How can you learn from these results to avoid or mitigate an impact? How can you reduce the impact? How can you monitor it to know if we are if our assessment was correct and if there is indeed a risk, or whether it was just some sort of an artifact of our analysis? And so any type of risk management that would come out of this is, in my opinion, kind of the most useful part of this, beyond just sort of doing that assessment and the initial identification of what those risks are.
Yeah, no, I think that's a good point as well. And one of the things that when we present our findings at public forums, a common criticism is that it's really rare for a human health risk assessment to get in front of the public and present elevated levels of risk. So somebody will say, look, I've never seen you actually identify an unacceptable level of risk. And why is that? And part of the reason for that is that the Hhra process is iterative. So early on in the process, if we start crunching numbers and we recognize that some of these risks are unacceptably high, there's an opportunity for us to go back to the air quality team or the water quality team or even the project engineers and try to solve that problem early on. There's an opportunity to say, look, these risks, because as far as I'm concerned, an unacceptable level of risk for human health is a showstopper with respect to an EIA. You really should never have a significant adverse health effect. Before you get to that point, I think there's an opportunity to mitigate those risks. And recognizing that there's going to be some level of uncertainty with respect to these risk estimates, that's addressed through an ongoing monitoring program. But the mitigation, the opportunity to go back and reevaluate some of the emissions and things like that, that's all part of the Hhra process. If that makes sense.
Makes great sense. And I'll also just tie this back to another concept in EIA, which is to be interdisciplinary and not multidisciplinary. So Bart talked about the human health risk assessor going back to the air quality assessor and saying, look, these results seem to indicate some adverse impact. How can this be mitigated? And that's what's really meant by that interdisciplinary. It's experts from different domains working together to solve these problems rather than everybody sort of going off into their little silos, doing their multidisciplinary assessment on their own and then submitting something at the end that didn't really bring much value to the project. So thanks, Bart.
Yeah. And there's one thing as well that I should mention as part of that is that there's an expectation now from agencies like the BC Ministry of Health and Alberta Environment Health Canada that these be conducted by qualified professionals, qualified risk assessment professionals. So what you see sometimes, that means that Hhra's professionals or practitioners need to stick to their knitting. Really, they're specialists in human health risk assessment. And there's a real danger when they start trying to influence the results and the findings of an air quality assessment or a water quality assessment if they're not experts in those fields. So there needs to be some separation, although it's fully interdisciplinary, there has to be some separation between those disciplines to make sure that an Hhra practitioner is able to rely on the expertise of a water quality specialist or an air quality specialist. So the objective of the problem formulation is really kind of to put, like I said before, some practical boundaries around the Hhra. The first step is to review the terms of reference for the project. And as well, even before that, you need to have a really clear understanding of what the project itself actually is. And then to review the terms of reference that are set out by the regulators, what their expectations are with respect to how they want to see health being assessed. You have to be able to define the assessment cases, the study areas. You have to be able to select the COPCs for the chemicals that are associated with the project. And then as well, the receptors of concern and the relevant exposure pathways associated with that project. So with respect to the assessment cases, depending on where you are in Western Canada, some provinces ask you only to look at a base case, an application case, and a plan development case. And then in BC, with the BC Ministry of Health, there's likely going to be an expectation that you also look at a project-only case. So the base case is, it's essentially, what are the existing conditions? So what are the conditions or what are the health risks under current conditions without the project? The project-only case stands on its own. So in the absence of anything else going on in that area or in that region, what are the health risks associated with that project? Now that really is kind of a hypothetical construct because in reality, that would never be the case, right? You already have existing emission sources in an area, or maybe you don't, but there's all these background sources of risk. But this is kind of a nice to know. I think it does help some regulators, especially when they start looking at things like incremental lifetime cancer risk, and I'll touch on that a little bit later on as well. The application case, which is already a cumulative case, that's the base case, plus the project thrown on top of it. And then finally, there's a plan development case, which is the base case project, so application case, plus planned projects, so reasonably foreseeable future projects in the area. Now, here's where things get a little bit tricky, and there's really not super clear guidance on how to do this, and different practitioners will handle this very, very differently. It's the whole chemical selection process. The idea is that you start off with a full chemical emissions inventory, so all the chemicals that could be associated with the releases from that project. That could be on the air quality side, could be the surface water quality side, could also be on the groundwater quality side. So your starting point could be hundreds of chemicals. It could include criteria air contaminants, so SO2, NO2, PM2.5. Could include reduced sulfur compounds, PAHs, VOCs. It could include an extensive list of metals and metalloids, so arsenic, cadmium, chromium, you name it. It could also include chlorinated VOCs. It could also include dioxins, furans. So this can be a really complicated process, and it's really important to make sure that you focus the HHRA on those chemicals of potential concern that are first off related to the project and likely pose the greatest risk to human health. So one of the challenges now, because of regulatory pressure, in some of the provinces you see practitioners looking at hundreds of chemicals, and it kind of overwhelms the process, but it also tends to distract from the real risks, because you end up probably focusing a lot of attention on what I would consider to be red herrings. So chemicals that pose a minimal risk or negligible risk, but they still need to be assessed quantitatively, and they still take up space in an HHRA. So really, they end up being a bit of a distraction, and it moves you away from what you really should be focusing on. And even this whole selection process, we could easily probably spend an hour on that, talking about that as well. So another part of the problem formulation is identifying the people who are at risk. So usually what you do is you focus on, and this is an image of a project that's in northeastern Alberta, where you see all the different receptor locations identified on a map. The focus tends to be on those locations that are closest to the project, so that are going to be most influenced by the project emissions. Then what we typically do is we also try to identify different maximum points of impingement. So where you expect to see the highest ground level air concentration, that could be along a fence line, or that could be a true MPOI. So the true maximum point of impingement inside of a local study area. And that will vary from chemical to chemical, depending on what the nature of the emission source is. So it could be a high level source, could be a low level source. The chemical could be volatile, a chemical could show a tendency to deposit early on, things like that. So that does vary according to chemical. And the idea being is just to get a pretty clear or robust idea of what the risks are throughout a study area. So the receptors of concern, you need to be able to define the different lifestyle categories or different groups of receptors. More often than not, that will include an Indigenous community. It could include, depending on where you are in BC, could be agricultural. And as well, it could include things like schools, cabins, sensitive receptor locations, could include old age homes as well. And then as well, there's a requirement to look at workers. So this is interesting. We're not looking at occupational risks with respect to the workers who are engaged or who are employed by the applicant, but you are looking at workers who are maybe housed in complexes or that are associated with other industrial activity in the area. The idea being is that the occupational health risks are covered under an occupational health and safety plan. So that's not part of the EIA process necessarily. And then as well, you want to look at receptors engaged in traditional land use activities or even in recreational use of the land. Typically, that involves more intermittent exposures. So you need to be able to acknowledge and account for that in the Hhra as well. So this gives you an idea of one idea of what a conceptual model could look like. So you've got the source on the far left of the picture, and then you've got the emissions into air, possibly into surface water, how that then gets carried through to sediment and soil. So releases into air, could deposit onto soil, could then be taken up by soil invertebrates, terrestrial plants, ultimately be taken up by wildlife, and then eaten by wild birds. And those wild birds could then over time be eaten by people. So this just gives you an idea of all the relevant exposure pathways and just how comprehensive a human health risk assessment can at times be. And
I'm not sure if you're planning to cover this, but how do you know where all of these people are either living or recreating, or where these receptors are out on the landscape? Do you gather that yourself, or is that up to a different team on an EIA?
Yeah, it can be a combination. So there are times when we've actually we've put boots on the ground, and we'll get that information ourselves, depending on the nature of the project. If you're part of a larger EIA team, often there's an opportunity to engage with the traditional land use team members, and they'll have a really good idea as to how that land is being used, where the cabins are, and things like that, and where all the sensitive receptor locations are. But if it's a smaller project, and if there's an opportunity to actually walk the land, and as well, we can rely on aerial photographs and things like that. So it depends on where the project is. Now, often when we look at that, so we can identify cabins on an aerial photograph, but we really don't know whether or not that cabin is being used. But to err on the side of caution, we'll assume that somebody could be there on a continuous basis as a starting point. So there's another way to show it, just again, to show that everything is kind of interconnected with an Hhra. You could have air emissions, deposition again onto soils, onto plants and things like that, how that could influence over time, concentrations in game tissue, and then what the impact over time would be with people eating those game, or inhaling the air, or even coming into incidental contact with some of the soils. So this is what a conceptual model would look like. Also part of the problem formulation. So the second large phase of the human health risk assessment is the exposure assessment, and that's where we quantify the potential amounts or doses that a person could receive through all relevant exposure pathways. So inhalation, skin contact, and ingestion. For the inhalation pathways, we're looking at both short-term and long-term risks because the project emits directly into air. The multiple exposure pathways really only focuses on chronic exposure, so long-term exposure. We don't do an acute impact assessment for multiple exposure pathways. And you look at primary and secondary pathways. When I talk about a primary exposure pathways, that means air inhalation and water ingestion. Secondary exposure pathways are people eating fish. So, you have an impacted water body. So that could then over time influence tissue concentrations in fish. And what does that mean with respect to human health? So you're considering things like air, soil, water, and food all together in the exposure assessment. So there's different ways that you can do an exposure assessment. You can either do it through direct measurement, which isn't typically done as part of an EIA. Direct measurement would be done with a large area contaminated site. So some of the areas in places like Sudbury or Flin Flon in Manitoba, where we'll actually go out and we'll take blood measurements or urine measurements. For blood, we would be testing for lead concentrations, and for urine, we would be testing for things like arsenic concentrations. In an EIA, what we do is we do predictive modeling. So we basically estimate or we forecast what the quantities will be over time. So a person, again, coming into inadvertent contact with soil, eating the foods and things like that, but it's all done through mathematical models. But in order to do that, you have to have a pretty firm grasp of what the physical, chemical characteristics are for those compounds, what the concentrations are in the different media, so how different type of environmental media or plants or organisms take up those chemicals, what the uptake rates are. But you also need to understand what a person's characteristics are, receptor characteristics, so what their body weights are, what their breathing rates are, how much of a specific type of food they eat, how much soil kids take in, and things like that. And then as well, you need to understand what the duration and frequency of exposure is. So how often is that person at that cabin? That's 10 kilometers down gradient from the project. And at what times of the year are they at that cabin as well? These are all things that need to be understood as part of the Hhra. Now, in the absence of that information, you have to adopt what we call worst case exposure assumptions. So if you don't know if a person's only there 1 day out of the week, then you have to assume that they're there on a continuous basis. So you have to assume that they're there 7 days out of the week for 52 weeks out of the year. So how do we decide which chemicals are assessed through the multiple exposure pathway assessment? Well, sometimes we just know because it's been well studied, so it's in the literature. We know that when we're looking at methyl mercury, that we need to look at fish tissue concentrations. There's also a process that you can go through that's been endorsed over time by Environment Canada, where you can do a chemical screen. So the first step is then that you look at the criteria for chemicals volatility. So you know that if a molecular weight of a chemical is greater than 200 grams per mole, then it can qualify for the multiple exposure pathways. If it's Henry's law constant or its vapor pressure meets certain criteria, then you know that it can qualify for a multiple exposure pathway assessment. Another step involves looking at a log KOW of the chemical, so really the opportunity or the potential for that chemical to bioaccumulate in the food chain. So kind of the rule of thumb is if the log KOW exceeds 3.5, then it qualifies for a multiple exposure pathway. And finally, the third step is you can do some fugacity modeling. So if a chemical potential concern exceeds 95% in air, or is less than that, then in theory it could be qualified for a multiple pathway exposure assessment. That third step, there's really no clear guidance on that. Steps 1 and 2, like step 3 is almost more professional judgment. Steps 1 and 2, have been endorsed by regulators in the past. And then the last thing that you could do is just use professional judgment. It's an EIA, and at times you're going to have to rely on professional judgment, but just make sure that the right person makes that determination.
So in other words, for professional judgment, you're relying on somebody who's done 10 of these at similar facilities and kind of knows what the right COPCs are based on, those other projects, and that's usually a pretty good bet.
Yep. Yeah, exactly. So they've done, like you say, they've done 10 EIAs. Let's say using a coal mine as an example, and they know very well what the COPCs are because they've just gone through it. They've got the experience to back it up. So the environmental media concentrations, that kind of refers to the collection of some baseline data as well. Depending on which regulatory agency you're dealing with, there's often a requirement to collect at least some baseline data, and that could be collected from soil, surface water. Sometimes it's collected from vegetation, and then often there will be some fish concentrations as well collected. Game meat concentrations, it's a much more comprehensive program, and it's not often done. Game meat concentrations are typically collected as part of traditional food quality studies, not necessarily as part of EIAs. There could be regional initiatives in place where some of that information has become available, but it's rare to actually see this being done in support of an industrial application. Now, I'll touch on this later on, but with this movement kind of towards a more robust or comprehensive health impact assessment approach, The federal government has now started asking for some of this work to be done for industrial applications. And I think that there's still going to be some back and forth on the best way to do that, because again, it is it's an extensive process. It's expensive. It can take a really long time, and the whole process itself of collecting this data can actually have an impact as well. And I think that needs to be acknowledged as part of that, as part of the HHRA. So the question is, what if measured data are not available? There are times when you're not able, or there are no baseline data. Then you have to rely on the modeled concentrations, so the predictions using mathematical models. And then doing that, you have to acknowledge the uncertainty as well. But ultimately, the idea is that you're combining measured data, measured baseline data, with predicted data. So the third stage of the human health risk assessment relates to the toxicity of chemicals. And the idea is really to get a sense of estimates of exposure that will not be associated with an adverse effect. So you're identifying exposure limits. That can be in the form of an air quality objective, could be a drinking water quality guideline. And if there are no TRVs or no exposure limits, there may be an opportunity to identify surrogates or analogs for those chemicals that have no defensible exposure limits. And then as well as part of the toxicity assessment, you need to determine the potential additive interactions for chemicals as well. So there's different ways that chemicals can act together. There's things like there's additive interactions, there's potentiations, there's synergism and things like that. But really when there's also antagonism, but what Health Canada wants you to do, and what the BC Ministry of Health sounds like they want you to do, is really just kind of focus on additive interactions as opposed to looking at things like synergy and potentiation, because there's just too much uncertainty with respect to those types of interactions. So the human health toxicity data tends to rely on epidemiological studies. So large-scale studies involving large communities. There's can be individual case reports, which isn't very common. We still tend to rely very heavily on in vivo, so animal studies, laboratory studies. Then the lab studies, in vitro studies, cell culture. If we start talking about things like mutagenicity and genotoxicity and things like that, we still have to often rely on those. And then as well, in the absence of any toxicity data, there is an opportunity to rely on chemical structure activity relationships. Basically what that means is that if two chemicals look a lot alike, and if they have, then we anticipate that they'll have a similar mode of action. So then you can combine those two, or use the toxicity information of chemical A as a surrogate for the chemical toxicity information for chemical B.
For the last 2 points, or the last 2 types of studies here, these are both indirect measures. Are these often validated?
With the chemical structure activity relationships is one.
And in vitro as well. Like, these are really extrapolating up to much larger types of systems.
They are, and they have been, but that's also the case for animal studies. And one of the ways that, yes, they tend to have been validated, but not always. And then you recognize that there's significant uncertainty, right, associated with relying on those types of studies. And then as a result, you have to apply what we refer to as uncertainty factors to the toxicological reference values, or the exposure limits. So you could have an effect in an animal, so at, let's say, 10 milligrams kilogram body weight per day, you see an adverse gastrointestinal effect in a rat. Recognizing that the rat system is different, or the rodent is different than the human gastrointestinal tract. So you apply, it could be an uncertainty factor of 1,000, right? So you're going from 50 milligrams per kilogram body weight per day to 50 micrograms per kilo. And it's not unusual to see the application of a 1,000-fold uncertainty factor, what some people still refer to as a safety factor built into the exposure limits. So there's different kinds of toxicity reference values, and so toxicity assessments by themselves, they can We can spend hours on that as well, but I'll quickly touch on some of these issues. There's a different way to assess cancer risks. We use that with cancer slope factor and unit risks. Cancer slope factors are for multiple exposure pathways, so ingestion, dermal contact. Unit risk relates to air inhalation. So the idea is that the higher the slope factor, the unit risk, the greater toxicity, the greater carcinogenic potency of that chemical. The idea when assessing cancer is that the regulators want you to assume that there's no safe level of risk, so that any exposure to a carcinogen could have some level of effect. The question then becomes, what level of effect is considered acceptable, or what level of risk is considered acceptable by the regulators? The last two, the reference dose and reference concentrations, refer to as non-carcinogenic risks. So the RFD is the estimate of daily exposure that is without an appreciable risk of an adverse effect during a lifetime. Same on the reference concentration, this relates to air inhalation. So the reference dose and the reference concentration are for non-carcinogenic risks, which are typically referred to as threshold chemicals. So in order to see some sort of effect, you have to exceed a threshold. That's not necessarily the case for the carcinogens. And this just basically lays out kind of the complexity of the different types of exposure limits that you can use as part of the Hhra. I don't want to spend too much time on that. So when selecting exposure limits, or what we often refer to as toxicological reference values for the human health risk assessment, there's a process that you have to go through. So you should rely on the limits that have been developed or recommended by regulatory agencies. Back in the day when this was kind of still in its embryonic stages, when we were just starting on human health risk assessments, practitioners, meaning toxicologies, often developed our own exposure limits. Now, as this field has evolved over time and it's much more mature, the regulatory agencies now offer databases of exposure limits, because a lot of the work has been done. And then there's a hierarchy that Health Canada likes you to use, and BCMOH does as well. The idea is that your first pick should always be Health Canada, and after that you can go to other primary sources. So that could include the US EPA, it could include the World Health Organization, and if there are no exposure limits available from those, then there's also an opportunity to go to other sources of information. So you could go to the California EPA, you could rely on limits from the Netherlands Institute of Public Health. They have them as well. You could go to the Agency of Toxic Disease, and so ATSDR, or the CDC in the US. There are other sources that you could rely on. There's two things that an exposure limit needs to be. It needs to be protective of sensitive individuals, so not just the general public, but it needs to be adequately protective of vulnerable individuals. And you do that through the use or the incorporation of uncertainty factors or safety factors. And it also needs to be supported by adequate and scientifically defensible documentation. So just because an agency has a limit out there, if it's not supported by anything, you need to reconsider its use in the human health risk assessment. So exposure limits can be available for individual chemicals, but they can also be available for chemical groups, so things like dioxins and furans and PAHs. So now we're getting to the final stage of the human health risk assessment. So basically the presentation of the results and then the discussion of those findings. So the risk characterization basically is a development of a ratio. What you do is you take the estimate of exposure and you divide that by your exposure limit, so your safe level of exposure. So what that looks like for non-cancer risk estimates is that you take, again, the predicted exposure divided by the exposure limit. That can be in the form either of an air concentration or it can be in the form of a dose. And the dose often is presented either as a microgram per kilogram body weight per day or as a milligram per kilogram body weight per day. The idea being that ratio is then below 1 then the risks are either negligible or they're low, even for sensitive individuals or vulnerable groups of the population. And when your ratio exceeds 1, that means that your exposure estimate exceeds your exposure limit. So that doesn't necessarily mean that there's going to be an adverse health effect, but what it does mean is that you need to think about the significance of that hazard quotient exceeding 1, how much conservatism has been built into the risk assessment, and whether or not there's a need then to go back and start advising the project engineers, the air quality specialists, the water quality specialists, to try to mitigate some of those risks. On the cancer side of things, again, I touched on this, agencies like Health Canada assume that any level of exposure to carcinogenic chemicals associated with some level of risk, hypothetical risk. So what that means is that Health Canada and other agencies like BC Ministry of Health have to kind of come up with an acceptable level of risk. So if in the case of Health Canada, that's 1 in 100,000. Quite a few states and agencies in the US, so south of the border, still rely on the 1 in a million. So they actually take a more conservative look at this. So the idea being that an incremental lifetime cancer risks that is equal to or less than 1 signifies that your cancer risk is below the benchmark of 1 in 100,000. So in theory, that means that, let's say you've got a benzene air concentration that's 1.5 micrograms per cubic meter, and in Canada you would compare that to an exposure limit of 3 micrograms per cubic meter. So you go take 1.5 divided by 3, and your risk is 0.5 in 100,000. So in theory, that's an acceptable level of risk according to Canadian regulators.
Just for context, I don't know if you know the answer to this, but if you take a random sample of, say, Canadian people, how many of those people will end up getting cancer out of 100,000? Do you know what the sort of general number of background risk is?
Yeah, it's shockingly high. It can be anywhere between 25 to 40%. So and there's a slide that touches on that as well, this idea that, we're dealing with a risk that's a 1 in 100,000, but when your background risk is probably closer to 3 in 10.
So in other words, 20 to 30,000 in 100,000, and we're adding 1 to that. Okay.
That's right. Yeah. Another thing that needs to be done now as part of the risk characterization, you have to have an idea as to kind of what the baseline health conditions are for the community surrounding the project. So basic demographics, personal health practices, some of the community members, focus being on health status and chronic disease. So I still think that this needs to be able to link back to the project and its emissions. So when you're looking at health status and chronic disease, I feel that the focus should be on things like respiratory types of disease, different types of cancer. If you're looking at respiratory disease, you should be focusing on things like rates of asthma, rates of chronic obstructive pulmonary disease. What I think I've seen, what I've struggled with before, and I've reviewed other people's work, or we struggle with this ourselves as well, is that you use a shotgun of blast. Like you just basically present everything that's known about that community, but it's not necessarily relevant to the application itself. So I think there needs to be some thought given to the relevance and the applicability to the project and its emissions. Sources of information, there's a fair bit of information out there from BC Community Health Profiles. So this, yeah, it's what I will say about that information is that it tends to be kind of broad in scale, and if you really want to get disaggregated data, so community level data, then it's going to be more challenging to get that information, and you may end up having to go through some sort of questionnaire or survey process to try to retrieve that. So the uncertainty analysis or the risk characterization, really you want to get an idea is what's driving the risks. So what are your grades? So, is it, if you're looking at a multiple exposure pathway assessment, are your risks being driven by fish consumption? Are they being driven by eating wild birds? And if it is being driven by wild birds, what's elevating those risks? Is it because you've estimated or you've modeled aquatic invertebrate concentrations? You don't have measured data, it's all modeled. There's lots of uncertainty associated with that. So as well, you recognize that there's going to be uncertainty with respect to some of the toxicity information. Some chemicals really have limited information with respect to toxicity. That needs to be recognized. And then you have to ask, are there ways to reduce that uncertainty? Would it help to collect additional data? Is collecting additional data pointless because you're not going to resolve the most significant sources of uncertainty? There is such a thing as the law of diminishing returns with respect to that. But I would say if you use a targeted approach and if you're going to collect additional data, make sure that the data that you're collecting is actually influencing your risks. So what is an acceptable level of risk? So who decides that? It's really a combination, but ultimately, when it comes to cancer risks, it's up to the regulator. It's not up for an HHRA practitioner to determine whether or not a cancer risk of 1 in 100,000 or 1 in a million is acceptable. That's been set by the regulators. So really what we're doing is we're just providing the results and we're offering advice. We're trying to contextualize the risks. Members of the public are also going to have an opinion about what's acceptable level of risk to them. I think depending on who you talk to, the notion of a 1 in 100,000 risk level may not be acceptable to certain portions of the population. And then the risk manager as well is involved in the level of risk and what an acceptable level of risk is. So Terry, this just touches on what you were saying, and we're using a pretty conservative estimate here for background cancer risk of 25%. But if you start adding things like that incremental lifetime cancer risk or the excess risk limit to that, you see that at times you could be going from 0.25 to 0.25001, right? If you're dealing with an acceptable level of cancer risk of 1 in 100,000. So there's one complicating factor with this as well, is that for the non-threshold, or sorry, for the threshold chemicals, so the non-carcinogenic chemicals, you're looking at those different assessment cases, the base case, application case, and the plan development case. There remains some question as to how you need to do cancer risk and whether or not you produce an incremental lifetime cancer risk based on the project alone, or do you then take an application case, you subtract the base case from that, determine the incremental lifetime cancer risk associated with that. Whatever you decide to do, you just have to make sure that it's really clearly documented. So then the weight of evidence in human health risk assessment. So whether a hazard quotient or an incremental lifetime cancer risk exceeds an acceptable level, it's important to also produce additional lines of evidence if they're available. That may take the form of some biomonitoring or epidemiological community health studies, but really ultimately you need to take a close look at what your assumptions are that are built into the human health risk assessment. Evaluate the key sources of uncertainty and see whether or not there's either an opportunity to mitigate some of those risks or to reduce some of that uncertainty by collecting additional data. Ultimately, the interpretation of the results, the contextualization of those risks, are we going to require a fair bit of professional judgment and then careful review by the regulators and any other external reviewers. But ultimately, that work needs to be done by qualified persons. And that's something that the BC Ministry of Health is going to be insisting on as well in their guidance for doing prospective HHRAs, and other regulatory agencies have had similar demands.
I'll just add to that as well. We've talked about qualified person in a few other contexts throughout this course. I get a lot of questions from people who are in 3rd and 4th year as environmental scientists wondering about, do I need to become a professional geologist or an RP bio? We actually had a lot of discussion about that in our last lecture when we had a guest lecturer who was an RP bio. And the way the BC government defines qualified person, it's not just somebody who's done a lot of the work in this area, but there are specific designations that you will need to do specific types of work. So make sure you've sorted that out before you graduate. Otherwise, you might be coming back to school for upgrading in order to become a qualified person.
Yeah. Yeah, for the work that we do, it can be done by PEng. I've seen professional engineers sign off on Hhras, and that's fine. Professional geologists, often professional biologists. We also have, for toxicology, we have what are referred to as diplomats of the American Board of Toxicology, which is a really rigorous exam process. It's horrible, and but there aren't very many of them out there. And you know that if a DABT signs off on anything that has a toxicological component attached to it, that you're going to be in pretty good hands, because again, the requirements are so rigorous. So one of the things that if you do, human health risk assessment really is it's a fascinating field because it is often interdisciplinary. You get to work with air quality specialists, water quality specialists, and you're talking about human health, or you're talking about ecological risks. So it's interesting, but it's also very, very challenging. And one of the most challenging aspects of our work is explaining risks, and explaining risks not only to regulators, but trying to explain and walk members of the public, people who are honestly concerned about their health, through these risk estimates, so like what they mean with respect to them. And there's a whole notion of reality versus perception as well. So I put this slide up to give you an idea as to what you would be dealing with. Like people are, their perceived risk of car accidents are considerably low when you compare it to what people are, how worried people are about things like terrorist attacks, right? But in actuality, the reality is that, one of the most dangerous, most hazardous things that we can do is get into a car, and as opposed to one of the safest things that we can do is get on a plane. Like but so that notion of perceived risk versus actual risk, there seems to be a real disconnect there, and that's something that we continue to struggle with. And at the same time, when you are communicating risks, this notion of voluntary versus involuntary risks, you have to be really careful on how you communicate that, because people are much more comfortable taking on voluntary risks as opposed to having a risk imposed upon them. So an involuntary risk. We all know that most likely the risks of getting cancer from a project in a remote area are negligible when you compare that to somebody who smokes 20 cigarettes a day. But you can't bring that up in a public forum, right? Because again, you're talking about a voluntary versus an involuntary risk. But so these are all things that you need to be mindful of when you start getting deeper into this field.
You certainly can't bring these up. However, I'll just use a personal example. I used to work overseas. I hated to fly. I would speed to the airport, chain smoke, and that was my coping mechanism when I was a youngster, was to chain smoke while I'm waiting for my flight and being panicked over my airplane flight, taking these ridiculously stupid risks with my life, worrying about something which is an extraordinarily low risk. People are just not good at perceiving any kind of risk.
No, you're absolutely right. And part of me always wants to put this kind of stuff into a human health risk assessment, but it doesn't really fit. It fits if used effectively through the risk communication process, but it actually doesn't fit into the EIA. So last few slides, I wanted to just touch briefly about how this field is changing. And so in the past, what we've really done, last 20 years, we've started to rely really heavily on this prospective human health risk assessment approach, right? 4 key stages: problem formulation, exposure assessment, toxicity assessment, and then the risk characterization. Now, the last few years, there's been a shift and a move towards what's referred to as a health impact assessment. The idea being that you look at health through a broader lens. So you're looking at things like social determinants of health, what regulators have felt, and this is really kind of developed in other parts of the world, in developing nations. So nations that don't necessarily have the regulatory framework that a country like Canada would. where you'd have large industrial players who wanted to develop projects in some of these developing nations, and the regulatory framework wasn't there. So they were held to certain criteria by, could be the OECD, could be other agencies, the World Bank, where they said, okay, we want you to look at health through more than just the environmental lens. We want you to look at things like physical environments, so air quality, water quality, noise, light, odor. But on top of that, start looking at employment, working conditions, social environments, health services, income, social status, gender, what that means with respect to health. So it's really kind of it augmented the whole process, this idea that and one of the challenges with that is that because HIA is I'd still consider it to be new in Canada. There's limited guidance on how to do one of these. There's a clear requirement for extensive engagement, extensive community engagement, more so than you would have for the human health risk assessment. On the left side of the screen, you'll see that there's kind of a process in place. There's a screening exercise that you go through to determine whether or not an HIA is necessary or even appropriate. So you could come to a full stop there. If you can show that an HIA is not necessary, then you don't have to go any further. That's pretty tough to do when the federal government tells you have to do a health impact assessment. So that screening exercise is probably already a done deal for a large of these industrial applications. Then you move to the scoping exercise. That's when you first engage members of the public and key stakeholders. And then from scoping, you talk to them about what your key determinants of health are, how you'd like to assess those. And then they've got influence on how that's then assessed, or whether or not you're even on the mark with respect to the determinants of health that you're going to be assessing. And there's a real loop back process throughout this, where you go from scoping to assessment to recommendations. You present those recommendations back to those stakeholders, and then if they don't like it, you're back to the assessment stage. So it's a much more drawn out process. There's lots of benefits for this HIA process, but there's also drawbacks. So really what you see is that we're moving, and one thing I should mention before I finish off is that that this HIA process still has the HHRA built into it. So it's not that we've completely set human health risk assessments aside. What's happened now is that the HHRA has become a component of the HIA. So really what we're doing is we're moving from what's traditionally been like a pure biological science, even at times where we've had to rely on mathematicians and things like that, sophisticated exposure modeling. So we're moving from a biological science much more to a social science. So with a pretty steep learning curve attached to it. So that's the way that health seems to be moving. And I think over time, over the next 5 to 10 years, there'll be a much more clear requirement for looking at health, like I say, through a much broader lens.
This ties in with an earlier lecture, and I just want to sort of recap some of what you just said for people who might have lost track of some of the acronyms we've been using. So human health risk assessment is more of a chemical exposure-based assessment. Right. HIA, or health impact assessment, incorporates factors like noise, light, odor, things where it might be a little more hard to quantify because it's more how do these things stress a person out rather than how do these stressors specifically change their biochemistry.
Yeah, so in an HIA, so a health impact assessment would look at things like, okay, what happens if you have a transient workforce that moves into a community and they introduce a higher rate of STIs into the community? How do you assess that as part of the health impact assessment? And then how do you mitigate that? And then you have a follow-up program. So you work closely with healthcare providers. You work closely with the different health regions in BC to kind of try to focus on what they consider to be the driving determinants of health. So all of that, and as well, you start looking at things like cultural practices, what that means with respect to changing cultural practices, whether or not that could have an impact on health.
Well,
Hopefully
thank you very much. That was a very interesting, nice overview of human health risk assessments and health impact assessments. So I really appreciate it. People have your contact info here and they can look up some of your work online. I'm sure they can find your work on many of the government registries. In fact, we'll be going through some of the registries later in this term, so maybe we'll pull up some of your work and people can have a look at it for themselves.
No, that's great, yeah. And if anybody has any questions, don't hesitate to reach out. Either you can give me a call or just send me an email. Be happy to hear from you.
Great. Thanks again.